Hello, welcome to this video. So this video is going to be focusing on doing a deep dive into the world of simulating networks. I know for you to be here, you've probably read a lot of theory about the world of computer networking, and you've been wondering what is like the best way I can start with actually building networks, not just talking about networks, simulating networks and building, let's say, a local area network. So if you've been thinking about doing that, this is the right place for you. So in this video, I'm going to be unpacking everything that goes on in networking devices. You've probably heard of devices such as the router. You've heard of devices such as, switch. We've heard of the hub. We have heard of end devices, which are also known as the hosts in a computer network. These are things such as a PC, your mobile phone, a desktop computer, and all the other devices which can be able to communicate in a network. Also, a printer can be an end device. We have also heard of things such as a firewall and a modem and so many other things. And the good thing is that we can be able to simulate all that using. So I'm going to be showing you, this is exactly what you are going to be using. I'm going to max this out. This is the software known as eNSP from Huawei. It was developed by Huawei. So now that we have been discussing about networks for a very long time, you've been exposed to the world of theory. How about we now start by building something known as a topology? So a topology is a layout. See how devices are laid out in a network. We call that a topology. And in eNSP, for you to build a topology, you just head over here and click New Topo. Once you do that, you'll be met with this blank screen. Don't worry, you can bring up a menu of options using Control L, and you'll see that there's this option of let's say devices. You can see there's a router, and there are so many other versions of routers. You can also click here to see that there are switches. So many other versions are also here. There's a firewall, we have talked of that. There are end devices and so many other devices that you need to simulate your network before actually building. So the reason why people simulate networks using software such as eNSP is because you first want to have that logical layout before you go to implement it physically. So if there is a problem with the logical layout, you can be able to sort it out using this software before you go and mess out in the actual physical world. Okay, so that being said, how can we start with a simple simulation of our network? So we know that a device such as a router is needed in a network. Why? A router is needed because it is a device which will connect two networks. So for a network to communicate with another network, a router must be in between. Let's say for the internet will not be able to do what it is doing right now, connecting us with the rest of the world if it were not for routers. So routers are actually doing the heavy load on the internet. So with that being said, you can just pick a router and drop it there. So like I said, we're not going to be talking too much about all that. Let's start by building a simple layout, a simple topology. So we have two routers, and we are going to also include a switch for a very simple network, and we will see how we can be able to have end devices communicate with each other. So this is actually going to want to make you understand commands. So commands are very important. We'll be unpacking all of that here. There are commands that you have to also understand so that you can configure a router, for example, to be able to route data packets. Exactly. So for the end device, we can just have PC there, PC there. So we're almost done. So the final thing we're going to do is to connect the devices, connect the routers to the switches to the end device. We're going to be using copper cables. So let's connect. Let's use the gigabit Ethernet ports for that. We'll also use that for connecting the switches. So this is going to be a very simple network. For now, we will also unpack other topologies later, but for now, for this particular video, it's going to be pretty simple. Okay, so there's a mistake I actually did. So when you're connecting a switch to an end device, you should always make sure that the device you are connecting to, for the switch part, you're using the Ethernet port. So here I use the gigabit Ethernet port. So that is wrong. You have to be consistent. So you will see that I've clicked this icon delete, and then I will select this one. Are you sure I want to delete this? Yes, I want. So let's do that again. Select here, then select Ethernet. Then for a PC, it will always have just one Ethernet port. Let's do the same here. Okay, so that's it. So this is our network. Bring that back. Okay, so this is our network. What can we do? What can we start by configuring this network? To have, for example, this PC talk to this PC and this PC talk to this PC. So you'll notice that this is a network. This switch is containing a network, and this router is also containing one network. So the first thing we first need to understand is, in the world of networking, there are devices usually communicate using IP addresses in a network. I said I won't dive deep into theory, but IP addresses are the ones used to identify a particular device in a network. So we have to come up with an IP address for each and every network so that we can configure the routers and we can configure the end devices. So there's the concept of public and private IP addresses. So the IP addresses that I'm going to assign for this network, for example, is going to be a private IP address. So 172.168.100.0 with a subnet mask of 24. So that is the IP address for the first network. Let's do the same here. 172.168 dot. So here we are going to have something like 99.0/24. So don't be confused, this IP address is not the same as this, because of .100 and .99. So let's use something like 192.167.100.024. So routers will usually have interfaces. These interfaces should also have a specific value which will determine the gateway. Okay, so here we can just give it a value of .2, and here we can give this interface a value of .1. We can give this one a value of .4, and this one we can just give it a value of .5. Okay, so once that is done, now we can now start diving into configuring. So before we do that, I will need you to come over here and activate or boot up all the devices on the network. So click this green play button to start all the devices. Give it some time. Okay, now that all the devices are on, you'll start seeing these red icons along the copper cables. They will start turning into green. So once they turn into green, you will know that, oh, my devices sorry about that. So you'll know that my devices are able to communicate. So let's try to see. Okay, the device is running, so it's still booting up. The routers are booting up. Okay, let's give it some time. So this video is going to be not really long. I just need to understand that for a network to work, you first need to configure the devices to have IP addresses. Once the devices have IP addresses, then you have to have the router have a gateway that is actively working to route traffic to the right destination. Another thing is, for routers, for them to communicate, we also have to configure a routing protocol. So we're going to do that today. And first step, let me type here, is to configure the IP addresses of the interface of routers. So that is the first step. I will have it here. So you get into this router and you need to configure the interfaces. Interface G001 or Gigabit Ethernet 001 and Gigabit Ethernet 000. So what you do, first of all, you are in user view. You must change this router to enter into system view. And also another thing to put into consideration is, when you are configuring your router, you'll notice that there are unnecessary information. Okay, I won't say unnecessary, it is necessary, but sometimes you just don't need all of that if you know I'm doing something which is right. So how do you turn off the terminal messages? You just type the command undo terminal monitor, or short for undo TM, and it will give you the information that current terminal monitor is off. Now after that, you get into system view. Okay, so once you get into system view, you identify the interface that you want to configure. Okay, I want to configure this interface, but my router, the name for my router is R2. I don't want this router to have the name Huawei. I'm going to type sysname R2, and it will change and assume the name R2, which is good because it will avoid confusion. So let's get into the interface G001, and once we are there, we will assign its IP. So IP address 172.168.100. Now I need you to be careful here. You don't put .0, but you put this value that we gave here, and we said that we are going to give it to this interface. That's what you're going to have there, .5. And then this this network has the subnet mask 24, and then you just finish off like that. Once you're done with that, you go into the interface G000, which is the opposite interface, and do the same. 172. So let's be careful here because the networks are not the same. So here we have 172.168.99.4, and you space out and then 24. So once you do that, you have successfully assigned IP addresses for the interfaces of router R2. You can quit. So you are successfully done with the first step. Head over to the next router and repeat the same process. You first undo terminal monitor and we change it to the system. So another thing that you should put into consideration is that you don't have to type system view, all of it. You can just type sys and you will be thrown into the system view. So sysname R1. So here we are going to also get into the interfaces quickly and assign IP address for this interface G00. As you can see, the IP address is 172.168.99.1. So I almost said 0 there. So you should also always be very careful when dealing with that. So space 24, interface G001, IP address for that is going to be 192.167. So .100.2 space 24. So once you're done with that, you can quit. So configure the IP addresses of the interface with the routers. You're done with that. So next step is that we are going to configure DHCP. So I need you to understand that there are two protocols that are used to assign IP addresses to the end devices on a network. One of the protocols is DHCP. I know you're probably wondering what a protocol is. So first of all, a protocol is a set of rules that govern how devices in a network will communicate. So one of these rules is DHCP. DHCP is a protocol that assigns IP addresses automatically to end devices. So how can we configure DHCP here in eNSP environment? First of all, we configure DHCP in eNSP on the router. Not unless we have a dedicated DHCP server. The router usually has its own internal DHCP server. So we just also get back into the router, and in the router we are in system view. Don't change system view. System view is usually used when you are configuring the router. If you are in user view, you cannot do anything, okay, to configure the router. So we type the command DHCP enable. So be very careful. These are the commands that are used to configure DHCP on a router, any Huawei router. So DHCP enable. So after that, you'll see operation will take a few seconds. So I think by now it should be done. So just proceed with your commands. So after that, we are going to create an IP pool. So IP pools are usually case sensitive, and if you have two networks connected to a router, one of the network is going to have a different IP pool, which the case is going to be very different from the other. So you cannot have two IP pools with the same name. So IP pool R2, let's start with the capital. It's successful to create an IP pool, so let's proceed. So we identify the network. So the network is 172.168.100.0. Okay, so that is the network. Don't put .5, no, just put it .0 and then mask 24 for this subnet mask. And then we're going to identify the gateway for that network, 172. Remember, we are facing this side. This is the network. Okay, I think after this one I will put a label of this is a network and this is a network, so that you don't confuse the two. So 172.168.100.5, that is the gateway here. And then we are moving into identifying our interface. So this DHCP, which interface is going to have the capabilities of assigning IP addresses to end devices? It's Gigabit Ethernet 001. So interface. So you don't have to, you can type interface in long form, or you can just type int G001. They will just work the same thing. So after that, you type DHCP select global, and then you quit. So once you're done with that, you can go ahead and enter into this PC or end device, one of them, and you'll see that in the basic configuration, you will find that for the IPv4 configuration, IP addresses are being assigned statically, but static IP addressing is something of the old or ancient times. Devices nowadays are not assigned IP addresses statically, because static IP addresses cannot be reassigned to another device. Okay, and once you assign a device static IP address, that means that IP is not going to be assigned to another device on a network. It sticks with that same device forever. So we don't want that. We want our IP addresses to always be cycled back. So here we're going to select DHCP, then we're going to apply. So once you do that, you come to the command prompt, that device, and type this command ipconfig/new. So it's going to take a few seconds, and then it should give you this information. So the first thing you're going to notice is IPv4 address is assigned here, 172.168.100.254, and the gateway, it has recognized its gateway. So PC1 has recognized that its gateway is that. So there are network testing utilities. Such one of them is a command known as ping. So ping is used to test if a device can be able to see another device in a network. It's like shouting in a network, shouting for the name of someone in a room, and they respond, "Hey, I'm over here." So it's the same logic, it's the same analogy. So we are going to ping the gateway to see if it will respond. If it responds, then our configuration was successful. So 168.100.5. So you will see that there are packets being sent, and 5 packets were transmitted and 5 packets were received. So that's exactly how that ping command will work. If you want to ping a device continuously, you just type ping 1. So another thing, sorry, before I move into that, you can just cycle back a command with the up key on your keyboard, up arrow, and then type /t. So this option is going to ping recursively. So recursively is continuously. So until you stop it using Control+C, it will stop. Okay. So once you're done with that, move into PC2, select DHCP, then apply. Repeat the same ipconfig /rename. Then it will just take a few seconds, and now ping the gateway 172.168.100. So it is successfully pinging the gateway. We can stop it at that and move into the next router. So here we're going to repeat the same DHCP enable IP pool. So this is R1, IP pool R1. We're going to create we're going to create DHCP capabilities to this interface G001. So we select the network 192.167.100.0 mask 24. Then you are going to identify the gateway for that particular network. .2. Yeah. So if you can see here, we said we select for a gateway, we select .2, the interface. Okay. The gateway is the interface IP address that we configured during the first time as we were configuring it. So yeah, so we type that, and then so after that we identified the interface G001, and then we say DHCP select globally, enter. Okay, and then we quit. So once we have done that, we quickly head over to the end device, select DHCP and apply, so that now this one will tell the device that I am open. It will tell all the devices that I am open to receiving an IP address automatically. So then you type IP config renew. Yep, so it is going to return that. You'll see the IP address that has been assigned and the gateway that we configured. So let us try to ping the gateway 192.167.100.2. It will respond. So that's a good sign. That means we don't have to troubleshoot. sorry. So the first command is ypconfig/renew. Ping 192.168.100.2. Okay, so since there's some kind of a problem there, let's try to ping again. Let's bring it back. .100.2. Okay, so we're gonna have to troubleshoot that. Let's see. So there's this command display CU. Let's see. So display CU is going to display the configuration. So let us see if Gigabit Ethernet 001 has DHCP properties. Yes, it has. So that's the case. Okay, so a quick correction here. So the network that I used here for this, so the IP address that I used here for this network is actually not a private IP address. So if you can recall at the beginning of the video, I mentioned that usually there are two types of IP addresses, and one of those type is private IP address. A private IP address usually works internally, okay, inside a network, and a public IP address usually is being used by routers to route traffic over the internet. So the reason for this is so that your internal network is protected from the external network, such as the internet. And as devices communicate from internally and want to send data packets outside to the internet, for example, there is a concept known as network address translation, whereby private internal IP addresses are converted into public IP addresses to be used in the external network, such as the internet. So with that being said, this IP address is not a private IP address. Private IP addresses are usually, so you usually have 192.168.x.x. This is usually most networks, even those that we use at home. If you try to check the device, the IP that has been assigned usually start with 192.168 and sometimes 172.168. So yeah, dot one all the way to dot 100. So that is usually the range. So if you are also following along, you should always remember that. So I was actually wondering what might have gone wrong, but I actually stated that, and after keen attention, I saw this mistake. So we're going to rectify that. So I'll also show you how you can rectify for this interface, because as you can see, this interface, Gigabit Ethernet 001 for router R1, has already been assigned an IP address. So how can you change that? So I'm going to be showing you right now. So let's change this one to 168.1.0. So once we do that, we come here, router R1, let's press enter. You notice that after staying for a while, it is in user view. So we're going to first of all undo terminal monitor. We don't want unnecessary information blocking our view, and then system view. So let's get into interface G001. So to solve that issue out, first enter into that interface, and we are going to undo IP address that we assigned. Okay, we assigned the IP address 192. If you can just remember up here, it was 192.167.100.2, the subnet mask of 24. So once we do that, we will have already undo that IP. Okay, so right now the interface has no IP. Okay, so now you assign a new one, IP address 192.168. Now you are careful because you're also looking at the network that you are using, IP address that you are using for that network. So .2 192.168.1.2 space 24. So once we do that, we head over here to this device because it was the one that was acting up. So we type ipconfig /ping. Let's do that. So the reason why that pinging failed is because the type of IP address that we used was not a private internal IP address. It was in fact an IP address that is to be used in the public. Okay, when we say the public, we mean the internet. So the internet has a range of IP addresses dedicated to it. So we are going to try to ping again 192. Okay, so let's do that again. So these are real issues that you will usually face when you're configuring your network. And once you face them, you have to go back and try to configure again and troubleshoot. So the gateway is still the same one, it doesn't change. So that means when you ping, you will still have the same issue. So the only way you can solve this out is to go back into this router. Let's quit and let's do a display configuration command and just press enter until you see the gigabit Ethernet. So in the previous command, DHCP select global was applied to the previous IP address for that gateway, but that gateway was wrong. Okay, and that IP address was also wrong. So what can we do? We can do DHCP enable, redo the same process. Okay, just redo the same process. IP pool R1 and then network. Select the network 192.168.1.0. Mask is 24. So it says please delete the network section first. So let's quit and let's do undo IP pool. So the previous pool had IP addresses that were configured specifically for the previous IP gateway that we had messed up. So we are going to undo IP pool R1 first of all because it was already configured then. So once we do that, it will prompt us their IP addresses are located. Are you sure? So we type yes. Now we start again. IP pool R1 and the network now. So once we do that, we just do the same thing. 192.168.1.0 mask 24. Gateway is 192.168.1.2. And so I'm just being careful so that we don't mess up again. So DHCP select global and quit. Let's put that away. Okay, let's do so basic config. We can select and apply again and come back. IP config /me. Give it some time. Hopefully it picks up. Fingers crossed. Yes, it has. So it has identified the correct gateway. So previously, even after assigning the right interface IP address, it still could not identify the right gateway. So now it has. So let's try to ping 168.1.2. So it still says that destination host is unreachable. Display sleeve. Okay. And let's try again IP config renew. Try to ping again. Yes, so it is working. So this has been configuration of the DHCP. So we are going to finally finish off with routing protocol. So these are the things that you need to take into account when configuring a network or simulating a network. So the routing protocol. So there are two routing protocols. There is a routing protocol known as static routing protocol. So protocols are used by routers to be able to calculate a path that they are going to take to send data to a destination. So there are two, not really two, but there are so many routing protocols. But in this video, I'm just going to talk about two, but we're going to simulate only one. Hopefully, in the next video, we will simulate the next one. So I need you to know that there is static routing protocol and there is OSPF, which stands for Open Shortest Path First. Okay, Open Shortest Path First. So what are we going to do today? And why do we even need to simulate routing? So we need to simulate routing because, as you can see, these are 1, 2, 3 networks, using networks tatu. So this device PC1 cannot be able to communicate with this device over APC4. Okay, because this router needs to know where to send its data. Once this PC has sent its data to the gateway here, it needs to know, oh, where can I send this data to reach a certain destination, and this destination is on another network. So for starters, this PC1 is able to ping. This PC1 is able to ping its gateway, as we saw, right? It's able to ping its gateway, and it's also able to ping this interface facing opposite to its gateway. So let's test that theory out. Let us test that theory out. 172.168.99.4. So it is able to do that, but it cannot be able to ping this interface G00 and G001. It cannot be able to do that. We have to set up a certain protocol. So we are going to, for this video, we are going to start off with static routing protocol. SPF, we shall be looking at diving deep into that in the next video. So there are commands that we are going to, first of all, we need to understand. So for static routing, we use the command IP route static unreachable network and its mask, and then next hop IP address. So this is just a format that I'm going to apply so that you can be able to see how it applies when you are configuring routing protocol in routing. So we have identified, so we are going to set this up for the two routers. So the first router is going to be router R2. Press enter. So again, handle terminal monitor system here. So the first command IP route static. Now, what is going to be the unreachable network? Remember, for router R2, it can be able to reach all the networks it is connected to. That is this network, okay, and this network. If you may allow, we'll just say this is network A, and this is network B. Okay, this is network C. Now, not PC, but router R2 can be able to connect or communicate with the network A and the network B, but not network C, because it is on the other side and it has been abstracted by router 1. So our unreachable network in this case is going to be 192.168.1.0, the subnet mask of 24, and the next hop IP address. Here the next hop is going to be this interface. So a router will send, using a hop, will send its data to the next router by hopping. So here data will come from this PC1, enter through the gateway and leave through the opposite interface, and it will hop all the way into this interface G000 of router R1. So this is going to be the next hop. So let's type the next hop. The next hop is going to be 172.168.99.1. That is the next hop. Okay, so we have configured that for router R2. How about we do that for router R1 too? So router R1, we are going to say, so it is already in system view and the terminal monitor has already been done. So let's type IP route static. The next, so the unreachable network is, in this case it is network A. And we have seen that Reachable networks are the ones that it is directly connected to. The router is directly connected to C and B. The router one is directly connected to network B and network C. So the unreachable network here in this case is 172.168.100.0 with a mask of 24, and the next hop is 172.168.99.4. So here, from here, data will jump all the way to this interface. Okay, that is going to be the next hop. So let's press enter. And once we are done, we can head over to the PCs and try to ping. So for instance, PC4 had an IPv4 of 192.167.100.4. Let's copy that and head over to PC1 and try to ping. So best practice is to try to ping all the interfaces and finally the gateway to a particular network. So we can start first of all. We pinged 000 of this interface .4. Let us ping of .1 and try to see if the router can be able to route the data packets well. So it started by saying request timeout, and somewhere along the way it was able to identify the path to take to route the packet. So that means our protocol is working the way it should work. So let's try to ping. Let's try to ping the interface for the gateway interface for network C 192.168.1.2. Let's ping that so it is able to reach that gateway. So if a device can reach the gateway of another network, that means eventually it can be able to penetrate and get to the end device of that network. So let's try to ping the so we remember the IP address of PC4.1.254. That so if it was able to reach the gateway, it will be able to reach the end device. So we just have to give it some time. Okay, so you see that. So the final message is that a packet was received. One packet was received. So we can now try to do that again to see that all the packets are able to reach the final destination, which is PC4. So with that, ladies and gentlemen, is the end of this video. But it's not the end of videos like this. I'll probably be making more, and like I said, networks are for the biggest part in network is simulation. If you're able to understand theory, then you can be able to apply that theory and see it in action in a simulated environment like eNSP. There are other environments such as Cisco Packet Tracer, but I find eNSP to be very straightforward and very easy to understand and learn, simulate networks. And Huawei routers are also widely used. So yeah, so I'll just end there. If you have any questions and would like me to work on something, need any clarification, I will drop the link to a Discord, something like that, and we'll keep in touch. Thank you for watching.